This talk is more a high-level talk. In the past, I've given like really low-level ones on like Rust and trait design and really, really boring things. These things are much more high-level and hopefully easier to understand. It's more about how does it look like to actually build a product using Polkadot? How do you compose everything together to the point where you actually can build something meaningful using the Polkadot tech stack? And that's kind of what we're going to dive into today. So just quick overview. This is the current way people really build on, quote unquote Web3, right? You have the meta protocols at the top. You have the layer ones. You have your rollups and smart contracts as kind of the middleware between you and those layer ones. And then you write, of course, the dApps at the bottom, which utilize all those different services. At a really high level, that's how pretty much every Web3 application works under the hood. And this is a quick intro to Polkadot because I wasn't sure on the level that people knew coming into this. So for Polkadot, obviously we have the relay chain, and the relay chain coordinates and orchestrates all the activity around the different parachains. And then of course those can utilize bridges to bridge out of the ecosystem, etc. And very briefly, again, parachains, they, on a more specific note, they utilize a collator to upload and verify via the parachain validation function called a PVF to Polkadot to verify that, basically saying, hey, my state is valid, and Polkadot says, yes, your state is valid. And then effectively, all the different states from all the different parachains can be condensed and represented via Polkadot's state root. So you can always go in Polkadot and know that all the parachain state is valid no matter what. And for interoperability, we use XEM. This is a term that you'll be hearing quite a bit. So XEM is a way for, it's actually a format, a messaging format for parachains to send messages to one another. But it's also kind of just a general message format you could use in many other contexts. So it's not really something, I mean, it is specific to Polkadot, but it can be used outside of Polkadot. In fact, there's some teams who have implemented XEM on the Ethereum side in Solidity smart contracts so they can actually receive XEM messages on Ethereum. But as a warning, you want to actually, some of this will change, some of these terms, parachains, relay chain, etc. We're going to be seeing things, instead of using the parachain protocol to validate the different chains, we'll actually be looking at using something called agile core time. You're going to see this term cores, core time, and it's kind of what you expect. It's representing compute on the network, right? Versus before, where we're kind of bulk buying a bunch of blocks in advance to run our parachain. Now we want to have more as a pay-as-you-go model by buying a core and amount of time that we use that core to run our computations for our parachain. And then likewise, the parachain kind of model or the lingo, I mean, it will stick around, of course, but it's more abstracted away into like a task now. So the idea is that you program or create a task which works with Polkadot and works with the core time model, and it can be a blockchain or a parachain or whatever, or it can be something entirely different, as long as it abides by Polkadot standards. So in other words, you have decentralized and generalized computes. And essentially, also at the bare minimum, like the tasks and parachains, all of this, they're essentially just WebAssembly blobs that are uploaded on the relay chain. And that's basically what your parachain is. And this is just like a visual representation of what that might look like. It's just really, really high level. Like imagine that all the different parachains now are just kind of utilizing cores as they need to use them. And you have kind of this like elastic scaling model if you want. Maybe you're using different cores. You can divide cores up. And so parachains can share cores. So you're not stuck with just buying like, flat out maybe 2 years worth of blocks. You can buy a month's worth of blocks, a week's worth of blocks, or pay as you go, etc. And that's kind of the idea here is you want to be able to utilize those blocks as you need to, not, have to put a big, capital intensive investment up into actually deploying a blockchain. And if you ever want to read up on this stuff, the Fellowship RFCs are basically the place to read up on the latest and greatest in Polkadot. So yeah. So let's get back to actually the development side of things, since this is what this talk is about. And this is an overview on developing on the Polkadot SDK. So you can really think of developing on Polkadot in 3 different kind of stacks. You have, what happened? Oh, there we go. You have stack 1, which is userland, right? That's just your client side. That's you writing your client side app in like React or Angular or whatever, and that talks to the blockchain, talks to the Web3 services, etc. Right? Sometimes we call these unstoppable apps. Sometimes they're called dApps or decentralized apps. And there's many libraries to build these client-side apps, right? You're not limited just like to the web, but you can use stuff like Rust. An embedded device can be a client-side app, right? You can build a client inside of a microcontroller and have that talk to Polkadot. You can use a library like subxt for that. You can also use other, there's numerous libraries, Python, Go, JS, TS, etc. And then kind of the second stack, which is oftentimes, can be a little hard to place, but right now smart contracts are kind of like the middleware of Web3. So they stand in between usually the dApp and then the layer 1 or the layer 0 or whatever. And on Polkadot, you can write these in either in Ink, which is a proprietary kind of Rust EDCL, or you can also write them in Solidity, since Polkadot supports EVM-based contracts on parachains like Moonbeam, or Star, and etc. And then stack number 3, which is the most abstract or maybe harder to grasp kind of thing, which is the protocol and kernel level of things. And this is things like the Polkadot protocol, writing blockchains, writing tasks, etc. This is really like the backend and backbone of these services. You can't really build the previous without having these in place first. So at a high level, this is how these things kind of operate. But let's go back into the role of Polkadot. So Polkadot, you can really think of it as a composer of protocols. So it takes all these different things, and the idea is that you can use all these things together to compose and build out a final product. You can either build these things individually, right? So you can build your own L1, your own L2/rollup type deal. This is actually something you can do. Smart contract platform, your own dApp, etc. You can build them together, or you can, you can build them individually, or just use them all together into one singular stack. And as an example to kind of, instead of talking about these concepts, there's an example I want to run through, which is imagine that we had some sort of setup where we had houses generating like solar energy, for example. So each of these houses, they're generating their own energy, and they want to sell their excess energy on some sort of market. Right? So our house is connected to many other houses. We can see kind of who's generating how much energy and how we can actually make money off of the extra solar energy that we generate. Or let's say someone needs energy, and for some reason on their particular location, there's like, where I'm from in Florida, you have clouds and like a mile away will just like stay there. So maybe they're not getting as much sun, but you're getting more sun, etc. So for that, let's kind of think this through. So we'll probably need our own protocol to allow houses to kind of join a network. So we might need to write a parachain or a task that runs on Polkadot to register all these houses. Then of course, we need a way to retrieve data from the devices which facilitate like solar charging and stuff. And then maybe we need a way to sell those units on some sort of exchange. So maybe you need a way to provide liquidity for those units in exchange for whatever unit you want to exchange it for. And this is an example of services that exist on Polkadot that you can use to build something like this. So you could use a DEX to list these units of energy and exchange them for whatever. You can use Asset Hub to actually create the asset representation itself. Then you could use an Oracle service, something like Accurast or Fala, and actually get data from like IoT devices, maybe ones that aren't even Web3 enabled, but you could actually use the Oracle services to enable them to talk to your protocol. And likewise, you can use these Oracle services, create your oracles on there, and then use XCM, which is how you pass messages, to talk to something like your own custom protocol, which is registering the houses. So you can see how you can kind of use Polkadot on multiple layers to build out this application. And again, that's essentially what I just said. But the idea is that you can use the different parachains for their respective strengths, put them together, even with your own protocol or without, depending on your needs, and then have a final product at the end of that. So that's kind of what that looks like. So you might have Asset Hub there, the Oracle kind of solution, then your chain, you have your front end, Polkadot on the top, orchestrating everything, and then you compose that into this singular platform. And of course, there's optional stuff like data indexing, things to make your life easier when you're actually developing these apps, which you'll probably be using. And under the hood, if you want to look at like what technologies are used, those are using Substrate/Frame under the hood, so the Polkadot SDK. And then your front end might be something like React, or if you feel like HTMX, Angular, etc. And smart contracts might be Ink or Solidity. So maybe you're migrating from an EVM-based platform and you want to put things over, at least as an intermediary on Polkadot. So you can also just use Solidity contracts. That's where you could use a chain which supports EVM and actually utilize that. So yeah, you can either just, as a developer, you can choose to specialize in just like one of these things, like building out just the layer 1 or just the front end or just this. There's places for you to actually focus on each of these 3 stacks respectively. And with that, I kind of want to go over just a quick word on hybrid chains, because this is a word which comes up a lot. You'll notice that I mention deploying smart contracts. And it's worth noting that Polkadot itself does not support smart contracts, but there's parachains that support actually deploying these contracts. Some chains are more geared towards that behavior of just deploying contracts, and that's how you interact with that chain. Others have their functionality all kind of baked in at the layer one, and you don't need to use contracts. But the idea of a hybrid chain in the future is that you probably would want to have both, where the smart contract will interact with the protocol in a way which makes sense. And there's a whole article on that, which is I encourage you to read if you can. But it's just a way of kind of separating those two concerns, since it's sometimes hard to see where they meet. So yeah, the previous solution was built using the Polkadot SDK. We have Frame and Substrate, which is how you build the layer one portion. Cumulus is how you talk to Polkadot from your blockchain, because your Substrate chain can just be a solo chain. It doesn't have to be a parachain, but to talk to Polkadot, you have to use Cumulus. Then, of course, the SDK also includes Polkadot itself. And Polkadot Substrate takes care of many moving parts for you. Things like networking, the runtime, storage, forklessly upgrading, things which normally would take you probably years of research and development to actually get together is already there for you. You're just focusing on building out the actual product itself. And I don't know if we want to go over all of this right now, but really when you're developing like a Substrate node as an example of kind of taking away all that complexity, you're probably only going to be focusing on like the runtime. You normally don't really need to worry about like storage or the client side. Like these things are taken care of for you. You focus on writing your blockchain. By putting together your different palettes or blockchain modules, you can then build your own blockchain and custom functionality. Right? And each palette has a configuration. You can change this configuration, or you can just remove that palette altogether, completely change the functionality of your chain without having to fork it and go through all of that trouble. And these are just some extra things on the runtime. We don't need to really go into those, to be honest. But yeah, and there's also easier ways to do this. Like I'm mentioning, these will take time to learn, these protocols using Substrate and Frame, etc. It's possible that you don't even need to do this. Maybe you can just utilize existing parachains or existing solutions to build out your product and just compose them together in a really smart way. That's ideally what most people probably should be doing. And just as a really good shout out, if you do want to deploy like an app chain, right, you can use something like Tansy. They make it really easy for you to just deploy an app chain really like in a few clicks. And that's how you can really get introduced. If Substrate is difficult for you, then a platform like Tansy would be perfect for you to start with to actually at least get some quick prototyping done, etc. And yeah, this just talks a little bit, and I won't go through all the details, but again, we mentioned Solidity contracts on Polkadot. That's what Frontier does. It lets you upload Solidity smart contracts to Polkadot because it actually embeds an EVM runtime, EVM block emulation, all that kind of stuff, all available for you in Polkadot. So what do you need to learn to do all this stuff? Well, Rust is ideal if you're working at the protocol layer. And really, this exclamation marks can be removed. But if you are going to be working at the protocol layer, yeah, Rust is definitely something you need to know. But again, if you're like familiar with front end and you just want to create apps which utilize blockchain services, then you probably don't need to know that much Rust. And of course, the mindset is really to innovate and bridge a bunch of solutions together, not just create things for the sake of creating them. It's really about bringing things which exist together in a meaningful way and actually solve a problem. And lots of things have been built so far using all this technology, right? Polkadot itself has been built using all these tools that I mentioned. Substrate gives you these building blocks just to build these decentralized systems. Everything is super generic. You can kind of fill in the blank with your consensus, block building, etc. And other things that you can build like a feeless blockchain deriving economic security from Polkadot. You can build custom consensus mechanisms. You can even build a chain which replaces like the account model, which is used in things like Ethereum and even in Polkadot itself. You could use UTXOs instead to track your state. And again, like the solar energy kind of example we kind of portrayed, you can also build something like that, like an actual platform. And yeah, these are just more things which have been built using Polkadot, like OpenGov itself. The biggest working DAO in the world right now is built on Polkadot as a series of blockchain palettes or substrate palettes. And there's many, many resources for you to actually get started on these different things like the Blockchain Academy, There's the Heroes program. We have some upcoming kind of core development courses that are coming up at the Web3 Foundation, along with numerous amounts of documentation also in the works. And of course, we can't forget about Web3 Summits 2024, which is really a defining event for a lot of Web3. If you still go on YouTube now and you look up a lot of these talks, you find that some really like key things, like Gavin Wood unboxing the MacBook and running Substrate in like a couple of minutes, like running a blockchain, like very industry-defining things usually happen at this event. So definitely go check it out. And you can feel free to scan this QR code. It has all the resources that I mentioned are inside of here. And yeah, that's it. Thank you, everyone.